Hey everybody, thanks for tuning back in. Today we're continuing our series with AWS Lambda. Last video we talked about setting up a Lambda behind a API gateway. So we route in traffic from the real world or from the outside world, hits API gateway, and that triggers our Lambda. So today we're building off of that a little bit, and we are setting up our Lambda to now talk to RDS. Relational database service. We're going to be using Postgres specifically, and we're going to be putting our Lambda RDS behind or inside of a VPC. So our RDS is not going to be exposed to the outside world. So if you knew the connection credentials, you could not get to it from the outside world. You would need to be inside of the VPC. To do that, we're also going to put our Lambda into the VPC. So we're still going to have real world outside connections coming in. They're going to hit the gateway just like we set up in the previous video. That gateway, just like we set up in the previous video, is going to hit Lambda. But the Lambda is now inside of our VPC, so we can talk to this RDS that we wired up. And I just put CloudWatch down here just because that's by default where all of our logs are going to go. So anytime we hit our Lambda and invoke our Lambda, there's going to be logs submitted to CloudWatch where we can kind of monitor and see what's going on. Same thing for RDS. There's a lot of logs that go to CloudWatch as well that you can check out. Yeah, so there's a quick architecture diagram. We're expanding off the previous video. So if you didn't see that previous video, take a look there. You'll need that code to start in with this video as well. But yeah, with that being said, let's get started and let's get started hooking up RDS here. So let's go ahead and hop over to RDS here and let's create a new DB. As part of this series, we'll create a database resource. We'll give it, we'll set it up within a VPC so that it's not accessible by public, and only AWS resources that we give access to it can actually access the database. So we'll click create database here. We'll do standard creates, Postgres, and if you want a specific version, you can choose it. I'm just going to leave their default here. I'm going to switch over to dev test. If you use production, you can get these kind of multi-availability zones. We don't need that. We just need a single. So a single DB, database one, that's fine. For our username, Postgres, that's good. If you'd like, you can auto-generate passwords. That's probably the most secure way to do it. For us, I'm just gonna type one in here. Make sure you remember whatever you type in, because we'll need it. We'll set the Lambda's environment variables to use that password. Okay, so for here, a couple different classes. These are all kind of the box or the machine that the database is gonna run on. Some of them are a lot more expensive than others. If we see we're in standard class now, we scroll down. It's estimating our monthly cost to be $118. We can get that a lot cheaper. If we go to burstable classes and then we choose the micro version, the smallest one, that drops our price down to 15, and we can make this a little bit cheaper. So we don't need auto scaling. That's fine. Solid state's fine. Allocated storage, 20 gigs is the minimum, so we'll just keep it there. So connectivity, this is where we kind of do security things for our database. We don't want to make it publicly accessible. We want to select no. So only devices inside the VPC can connect to our database. That's good. If you want, you can create a specific VPC. Like for example, if you have one AWS account and you have a bunch of different services or applications running on it, you'd probably want to create a different VPC for each one. We're just going to use default for what we're doing. Default subnet group, no public access, and we'll just existing. Yep, default's good. Don't care about availability zone. Database port, this is 5432 is standard for Postgres, so we'll keep that. If you want, you can increase, so you can use like IAM access or Kerberos. We're just going to stick with password. Additional configurations. We don't care about automated backups here. For our initial database name, let's just use Postgres. Encryption, sure, that's not super important, but we'll use that. And let's see, we'll keep the rest of this. Okay, so we see we get much reduced from that like 120 cost. We're down to about 15 bucks a month. So let's create this here. And remember the password you typed in, and we're on that default VPC. So now we need to jump back to our Lambda, and we need to do a couple of things here. We go to configuration. We're going to, let's see, that's fine. We want to modify this role right here. So let's select the role. And when we created the Lambda, this role got created for us. And we want to attach another policy. Let's see. It's filtered by Lambda. And the specific policy we want here is VPC access execution role. This gives us the permissions we need to kind of talk to other services and run commands across the VPN. Okay, so let's attach that policy. This lets our Lambda talk to our RDS basically. All right. So this role is saved, it's updated. Let's go back to our Lambda. And then on the left-hand tab, once we're in configuration, you can see environment variables. So remember, we need a password. So let's just type in the password. Okay, we'll need a couple of other configuration variables here. Let's see, we'll need the host. This is the endpoint within the VPC that the RDS lives on. We'll need the host. Port is going to be 5432, so we don't need that. Let's remove this. So let's get the host. Let's save, and I'll need to actually go to RDS, and we'll find the host here. All right, so on RDS now, let's click DB instances. And here's the database we just created. It's still creating, so let's see if we have the host available to us yet. Okay, so we don't have the host available yet, so I'm going to wait here. I'll pause here until the host shows up. When it does, I believe it'll show up right here under endpoint once our database finishes creating. All right, so our database is finished being created, and we see here, now under endpoint, we've got our host. So let's select that. And we can jump back to our Lambda. And now we'll plug in that host variable name, environment name, that host variable into the environment variables for our Lambda. Let's add a variable. We'll say host, and we'll paste in that variable. Okay, so let's save it. All right, so we've got host and password now. Let's jump to our code. So this is where we left off in the previous video. If you haven't watched that, we set up an API gateway to talk to this Lambda so that we can actually make external requests and communicate with our Lambda. So we're going to make a new folder here, and we're going to call this, let's see, we'll call this database. You can call it whatever you'd like, and we'll make a new file. We'll call it database.go, and the package is going to be database. All right, so we'll need a couple of variables here. We're going to need host, and this is going to be get-env. We're going to pull this from the environment, and that was host. Password, we're going to pull this from the environment as well. And that was password. Port is just 5432. The user, when we created our RDS, our Postgres RDS, it was defaulted to Postgres. There was a field on the creation screen that you could change. So if you didn't want to use Postgres, you could put something custom. Up to you. And I believe we need one more database. That's the default database here, and we made that to be Postgres as well. Okay, so we've got these environment variables here. Let's hop to the next step. So let's make a function on get connection, and let's have this return a SQL.db and an error. Okay, so we're going to get, let's change database to database. So we're going to build that, and we're going to hit SQL.get open. And Postgres is the driver we're using. And the data source, that's that PSQL info string that we just built here. So one thing with these, with the data source, you need to also import, with the driver name, you need to import that specific driver. The one we're using is going to be PQL right here. It'll be this one here. And basically we need to go get that and we need to import it. So we can do that here. Yep. So we'll get it, and then this is going to be imported as well. Okay, so you have to import this, whatever driver you're using. If you're using MySQL, Maria, whatever, you need to also import the driver. That's required for this SQL.open to function correctly. So what does this return? This returns exactly what we need and an error. So we can just return this, and what's it complaining about? Has wrong type of string port. Okay, so this needs to be an int. Okay, so that'll return our connection. So now in main, we can set this up. So let's make our DB now, and let's do SQL.db. And remember, for Lambda, these are going to be our global variables that we can use between invocations. So once you run a Lambda once, it's going to be basically booted up, and that thing's going to stay alive for some unspecified time. AWS controls how long the Lambda lives. It could be 5 minutes, it could be 3 minutes, something like that. But if you have a bunch of requests coming in, it will reuse that Lambda. So we'll be reusing the connection. We won't be creating hundreds or thousands of new database connections each time somebody queries our Lambda. There'd be one connection, basically, per Lambda. Okay, let's set up the DB here. So we can say DB, let's call this DB connection, and an error is going to be get DB database.get connection. Okay, and let's see if error. We'll handle that. Otherwise, we'll set our DB to equal DB connection. So if there is an error, let's see. Let's just we'll log that out. And we'll do a panic. So the Lambda would crash. Okay. So if there's an error, we're going to log that error. We'll also zap.error. This basically formats it nicely and prints it out so we can see what went wrong. Otherwise, we have a connection set up. That's good. One other thing we can do is just db connection.ping. We can ping this here to make sure it's alive. So if error doesn't equal nil. So pinging the database makes sure we can actually connect to it and we can communicate with our database. Pinging error, pinging database. And we'll also zap the error. Otherwise, we've successfully connected the database. We set our global variable and we're good to go. So we're going to do 3 new endpoints. One of the endpoints is going to be for migrations. We want to create a table. You can handle your migrations however you'd like. For us, we're going to put an endpoint, and we'll just call that endpoint. It'll be like get/migrate, and that will run a really basic migration script and create a table for us. And then we'll have one endpoint to insert a row into the database and one to retrieve all the records from our table. So let's set up that migration here. Let's do const employees table. Create table, employees. Let's pull up the Postgres docs. All right, and I'm just going to copy this down, and we will. We'll have an ID. We'll have an email, and then we'll have a first and last name. I'm just going to set these to varchar. And again, this video is not really about Postgres itself, so if you're wondering what any of this is, look up some guides for Postgres. Pretty straightforward to pick up. Okay, so there's create employees table. Let's call this SQL. Now we'll make a function to do this. create employees table. This will pass context, so we'll take it a context, and this will also take a database connection. And we'll just return an error. And what we can do is just db.exec context. We'll pass in the context, and then we can just pass in our create table SQL. And what does this return? This returns a result and an error, so we just want the error. And let's return the error from the function. Okay, so this is going to try to create the table, return the error if there's any. We use context here, just good practice if you're not familiar with context in Go. If the request basically gets terminated, like midway through processing, by passing this context, the query will also get terminated as well. So you won't have like really long running queries if the user isn't even waiting for the response. Okay, let's make this capital so we can use this outside the package. Create employees table. Okay, so let's add, we'll just modify this endpoint, migrate, and we'll run database.create employees table, and this will take that context that we get from the handler, and this returns an error, and if that's not nil, we're going to return this error response. Could not create employees table, and let's just return this comma nil. Otherwise, so if we get down to this line here, we've successfully created the employees table. We're going to return OK, and we're also going to return just this success here, kind of a success message. Let's see, body. Let's see, what is this complaining about? It needs to be a string. Okay. So if this went wrong, some kind of internal server error will return here. All right. This should be database. And what is this complaining about? Also needs the DB, so we need to pass DB. And that's just our global database variable. Okay, so for migrate, what we're going to do is we're going to call database.create employees table, try to run the migration script, the really simple one that we set up. If there's an error, we're just going to return that error. Otherwise, we'll just return success. All right, so there's the first step here. Inside of databases here, let's create a new file. We'll call this employees.go, and this is going to be package database. And let's make our SQL. So the first one is going to be inserting a new employee. So create employee SQL. And we're going to say insert into employees. We want to do email, first name, last name. And let's make this look a little nicer. Values 1, 2, and 3. Okay, that ID column here, this serial, is going to be auto-generated for us. This is kind of like the primary key, and this will be auto-generated and auto-incremented as we create more. These values here, 1, 2, and 3, this is we'll pass these in as arguments into the query. Let's make the function create employee. This is going to take a context as usual, and we'll take an email, also a database, so sql.db, and then we'll take our email string, first name, and last name string. And we'll do db.exec context, and let's see, we'll pass our context, we'll pass our create employee SQL, And then we need to pass our args. So those args were email, first name, and last name. And we just care about the error, return error. And we need to add the return type to the function. Okay, so we're going to execute the query. We're passing in the arguments, and then we just return the error if there's any error. So that's in create employee. Next, let's do get employees. And we're going to do select star from employees. Just a simple query. We're going to need a type here as well. So we'll say employee. It's a struct, and it's going to have an ID, which is going to be just an int. It'll have an email, which is a string. It's going to have first name and last name. JSON first name, and let's set that up here, last name. All right, and let's do the function now that'll actually run this query. Get employees, we'll take the context, we'll take a DB, and that's all we need. And we're going to be returning an array of employee objects and an error as well. Okay, so let's see, we're going to set this up. Make, this is an employee size 0, so we're going to make an empty array here. Let's return employees. We're going to make this empty array of employees, and we're just going to set the size to 0. And now let's query. So we're going to do db.query query context here. Pass in the context, and we're going to pass in our get employees SQL. So get employees SQL. And this is going to return a rows, a SQL.rows object, and an error. So rows, error. Let's handle the error. Otherwise, for rows.next, we're going to read in data. So let's see. Let's hop into the go.dev docs here. And okay, so one thing I forgot to do is deferring this close. So we need to close the rows whenever we're done. So usually the easiest way people do that, just add it right below your query with a defer statement. This means it'll run at the end of the function when the function returns. So for rows.next, we're going to make a single employee object, and then we're going to scan into that object, and then we're going to append that onto our employees array. And then at the end, we'll just do a quick error check. So let's bring this here. I'm going to bring this down here. Okay. And let's scan this in. So we'll say employee, 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 employee. So we'll scan the ID, the email, the first name, and then the last name. And we don't have this object. Return employee. Otherwise, let's bring this up right here, and then we'll say we're going to append the employee we just made onto our employees array. I just prefer this syntax versus var. If you'd like to use var, you can, but I just prefer this syntax here. Okay, so if rows.error, so we're going through each row, we're scanning the row into this employee object that we just created above. If there's any error, we're just going to return nil. We don't have any, there was an error retrieving employees, and we'll return nil and that error. Otherwise, we append that new employee that we just scanned onto our employees array. At the end down here, we're checking if there was any error pulling anything out from the rows. If there was, we want to return nil and that error. Otherwise, we've made our employees array object, and we're going to return that with a nil for the error. Okay, so there's get employees, and there's create employee. So that looks good. We'll debug this when we deploy it and test this out. Okay, so we have migrate. Let's do else if. Let's set this up. Okay, else if event.path equals slash employees, and event.path equals event.method we want. We'll say http.post. So this is going to be for creating employees here. Create a new employee. And then this next one is going to be for getting all the employees. So event.path. Okay. So in the previous video, we didn't talk about this really, but you can also check the method, right? Usually for an API, you'll have a single entity. For REST, you'll have an entity as the endpoint, so like employees, and then you'll have different methods, different actions you perform on that entity. So post, we're going to create an employee. Get, we're going to get all the employees. So let's do get first here. Let's say database.get employees. This takes the context and the database, and this should return employees and an error. If the error isn't nil, let's handle that. And we'll see. Error fetching employees. Otherwise, let's build our response. We'll build our response. Oops. And we are actually going to want a new response type. So this default response is good for like errors or just basic requests. But if we want to return like an array of employees, we'll make a new response for that. So type get employees response. We'll call it a struct, and we'll just put one item in here. And this is going to be a type of database.employee. It's going to be an array of database.employees, and let's call this employees. Okay, so employees. So if there's no error right here, we're building out the response object. So we'll say get employee response. That's the type that we're going to return. And we want to say employees. And we're just going to pass that employees array that we got from our database. And we'll return that. We'll return that right here. Okay, so there's getting all the employees. So let's get, let's create a new employee now. So first, also another thing we didn't cover in the last video, we can retrieve the request body. So let's do a json.unmarshal. And this takes the data and then the interface that we want to unmarshal it to. So we'll do unmarshal and event.body. So this is the body of the request that got passed to the Lambda. And then let's say, here's an employee. So we can set up our employee object here. Pass the address. And this returns an error if there's any issues. Let's handle the error. So if the error isn't nil, that means there was some issue with the request body. So maybe they're missing a field. Maybe it's a bad type, right? Maybe email was an integer instead of a string like we're looking for. So for this, we'll say bad request, and then we'll pass the error back also. Status bad request, and we'll pass the body that we just marshaled up here. Okay, so otherwise we have that employee, so we can create it. So database.create employee, we'll pass our context, our DB, and we need these values: email, first name, last name. So we'll do employee.email, employee.first name, and employee.last name. And this just returns an error. Let's handle that error. And in this case, something went wrong at the database layer, so this is like an internal server error. This is like a 500. And what is this saying? No new variables on the left side. Okay, so we already set up error above. Otherwise, we're successful and we've created our employee. So this is okay. This is okay here, and we can just put in a simple message. Success. Okay, so there's our two endpoints now. We've got a post on /employees that'll actually create one in our database. We've got a get on /employees, which just gets an array of all the employees we've created. And that first one up here was a migrate. We'll say ran migrations. All right, so there's a really quick setup. Here's our database configuration. Yeah, so let's go ahead and generate our function, and let's upload this to our Lambda now, and we'll hopefully everything runs okay, but if not, we'll debug this live here. Go back to Lambda, we'll go to code, and let's upload from zip. So we've got our function, and let's save it. Okay, so we've uploaded our Lambda. This may take a little bit to start running, but let's go ahead and run migrate here. So don't worry, I've got all the data in here, right? The email, the first name, last name. That doesn't matter. Our Lambda is not really going to care about that. But I have the request set to get, and I have the endpoint set to migrate. So let's run this. Okay, so we're getting this internal server error. I think I found the issue here. We set up our RDS to not take public connections and only work inside of a VPC. So we also need to wire our Lambda up to live inside that VPC as well. So inside of our Lambda and configuration VPC, we need to configure that. So here we select that default one, and then let's get all of our subnets as well. And we'll select our default security group. So this is all the stuff that we put for our RDS, just these default ones. Okay, and let's save that. So this should give our Lambda access to the database now. So we're updating the function, and then once that's done, let's go ahead and rerun that curl command. Okay, so we've updated that VPC. We've updated our Lambda to have access to the VPC, and now if we hop back over here, okay, just the path, any method on migrate. So let's run that. Okay, so we see ran migrations. So that should create the employees table. And now if we run get employees, we see we have an empty setup here we've got an empty setup. So let's go ahead and create our first employee. So if we do post on that employee's endpoint now, we're passing in our email, first name, last name, and let's do that. We see we get success back. So an employee should have been created. Let's call get again, and we see, yeah, we get an employee back. So there is our first employee. We can create another. And now we see we have two employees, ID 1 and 2, and just the same data because that's what we created it with. Yep, so there we go. So that is a quick run through of how you set up a Lambda behind an API gateway, and then also connect it to RDS. We have 3 endpoints. If you are going to use this in production or kind of use this for your own product, I'd recommend pull out this migration endpoint, either put it in a separate Lambda, maybe call that from your build pipeline. If you're on GitHub, as part of GitHub Actions, maybe have your build trigger this endpoint to run these migrations in case you make any changes, or just have some migration scripts in here. You could have some SQL files inside of your database folder, and you could kind of import those and run those when the Lambda starts. Yeah, so there is kind of how you do it. hope you found this useful. Hope this is able to help you out and get you kind of up and running with Lambda and RDS. And please make sure to like, comment, and subscribe to the channel. Really helps me out, lets me know I'm doing something right, and keeps me motivated to make more videos for you. Thanks for watching, and I will see you next time.